Okay, so a particle is sort of placed at A and then is released, isn't it, from rest, and then slides down and is smooth inclined plane and reaches B, which is 5 meters further along. Okay, and it says in A, then find the potential energy lost as the particle moves from point A to B. So remember now, potential energy, okay, is energy sort of a body possesses due to its position. Okay, obviously gravity can affect it, can cause it to move. Okay, and the formula for it, okay, is obviously then the weight, okay, which is mg times then the sort of relative height. Okay, so mgh if you remember. Now, what might be best here, okay, with this sort of setup is to actually draw a triangle from A to B, okay, such that A is at the one end of the triangle, B is at the other end, okay, and then we put our 20 degrees here. Okay, so you might find that a little bit more sort of useful. Okay, and we know, of course, then that's travelled 5 meters. That's the distance there for that hypotenuse going from A to B. Okay, and let's complete a triangle here. Okay, I say that because it will be a right angle triangle, obviously. Okay, and this side is what I'm going to be interested in, because in part A it says find the potential energy lost as the particle moves from point A to point B. Well, if I think of B as being the ground, okay, I need to measure what energy, potential energy it had at A to start with, and then it obviously lost it all as it got to the ground at B. Okay, so we can call B our ground if we want, where there's zero potential energy here. Okay, you can define zero potential energy wherever you want. But it's got potential energy up here, isn't it? So what we need, of course, is to use this formula, but we need the height. And remember, the height is not going to be 5 meters, because that's measuring the slant. We actually need this here. We need the vertical distance here. Okay, that's our height there. But you see you've got a right-angled triangle, yeah? Okay, and of course, we know this is the opposite side of our angle, and this is our hypotenuse. Okay, so I can use trigonometry to work out the opposite side. So it'll be sine, won't it, over h. So sine 20 degrees will equal to the opposite, which is just my height, yeah? So I called it little h, over the hypotenuse, which is 5. So then that means then my height, take the 5 up, will be 5 sine 20. Okay, so I can say that the height of A is equal to 5 sine 20. Now I won't work that out for a minute, okay, I'll just leave that there for a minute. Now I'm going to work out the potential energy that's been lost from going from A to B, so it's fallen to the ground, so to speak. There's my height, so the potential energy lost will equal to mgh, okay, so the mass is 4 kilograms, so 4, g is 9.8, and the height is 5 sine 20. So we'll work that out on our calculator. I get 67.04 joules there. Okay? Right, so that's A. Now in B it says then hence, right, it's a new word, 1 mark, hence write down the kinetic energy of the particle when it reaches B. Now if you think about it, it had 0 kinetic energy at A, yeah, because it was at rest, we are told in the question. So it had no kinetic energy there, but at B it's got kinetic energy, isn't it, because it's moving. What's happened, of course, is that the potential energy that's been lost has been transferred to kinetic energy. So we can say here, the kinetic energy gained, okay, is equivalent to the potential energy that's been lost. Okay, so basically the kinetic energy that's been gained is 67.04 joules. So that's the answer there for B. Okay, just switched from potential to kinetic. Okay, and then basically then with the last part then, it says hence find the speed of the particle when it reaches point B. Well, it's got that amount of kinetic energy, so if the kinetic energy is equal to 67.04, remember the formula for kinetic energy is half mv squared. So the mass is 4. So all you've got to do then is work this bit out, there obviously that's 2. So v squared then will be, just reversing this formula, 67.04 divided by 2, okay? So get 33.52, and then obviously to get v then, I need to square root that, so I get my answer to be 5.8 meters per second.